Amazon Web Services and Introduction. The session we are having today would be centered around giving an overview of Amazon Web Services as a cloud provider, as a cloud services provider, as a cloud platform. And before we even go into the specifics of AWS, we would briefly touch base upon cloud computing, which is nothing but a paradigm that involves delivering on demand computing resources over the internet. We are living in an era where we can access services, could be a resource, or could be a storage, could be a VM, could be a server. We can spin up a server over the internet. We can create some storage space by accessing services over the internet. Having said that, there are some key characteristics of cloud computing. The first one, of course, I have just spoken about on demand self service, which is nothing but ability of some users to provision and access computing resources such as servers or storage as needed without requiring human intervention from the cloud service provider. The second aspect is broad network access. Cloud services are accessible over the network, allowing users to access their application and data from various devices. Could be a computer, could be a laptop, tablet, or smartphone. The third very important aspect is resource pooling, which is nothing but the sharing of compute resources among multiple users, enabling efficient utilization and scalability. Typically, cloud service provider has the control over the allocation of resources. Users typically have no visibility or knowledge of exact location of the resources. This is how the model works. Then rapid scaling up and scaling down of resources could be in response to changing demands. So the ease and agility to scale down and scale up the resources is one of the key characteristics of cloud computing. And of course, if you are utilizing services, you need to pay. You need to pay the money. That again is a very calibrated model. We call it a measured service, whether it's a compute instance being provisioned by a user. There will be a model centered around the usage in terms of number of seconds or minutes for which the server has run. So definitely there will be some costing model around a service. So having said that, I would move on to the deployment models that cloud computing offers. So let me move on to the service models. As you can see, it's important to understand there are three service models, primary service models in cloud computing. The first one, infrastructure as a service. The second one, platform as a service. Third one, software as a service. It's important to understand these concepts because the services that are being offered by the cloud platforms like AWS, they are centered around these service models. So we'll start with infrastructure as a service. As you can see, it provides virtualized computing resources over the internet. Could be a virtual machine, could be storage, or any other fundamental computing resource as a service. So when these fundamental computing resources are provided as a service over the network, over the internet, it is called as infrastructure as a service. Users typically will have control over the operating systems, applications, and configurations running on the infrastructure. So as you can see, the control wise, users are able to customize to much greater extents. So basically, The users are gaining more flexibility over the physical infrastructure, and they can maintain better to meet their computing needs. Having said that, there are some of the examples, as you can see, could be a VM, could be a network. So there are service consumption models, as you can see in the last. There could be a time-based billing, as I just mentioned it. In case of a virtual machine, could be billed by minutes, could be billed by number of seconds for which the VM is running. So let's move on to the platform as a service. So a slight change here. Um, so the past platforms, they handle scalability, security, maintenance tasks, allowing for faster application development and deployment. So the key here is a developer should be able to start development and deployment of applications quickly rather than worrying about, you know, the underlying software. So past models provide all the software features and tools needed for application development. Because the service provider, the cloud service provider, will manage the backend infrastructure. So this is called as platform as a service. The third is software as a service. A very common example is YouTube. We just go to the YouTube link and we can watch the videos. And of course, there would be a subscription that the users can subscribe to. So user access the applications through web browsers or dedicated interfaces without the need for installation or maintenance. That is what is happening in YouTube, or for that matter, applications like Gmail. So SaaS providers manage all aspects of software delivery. Could be infrastructure, update, securities, everything. So moving on to the definition. So as we just discussed, it's an on-demand self-service, could be accessed from anywhere, highly elastic. Yes, we can provision the number of resources as we need. Yes, we can quickly spin up the resources. So agility aspect is definitely there. I can explain that better. There used to be times when there used to be a comprehensive process. If we have to, let's say, spin up new infrastructure in the data center, there used to be a thorough process, thorough approvals, which used to take weeks. There used to be a process of shipping the actual servers to the data center, after placing the order. So all those things were there. But in today's time, we just have one UI. It could be a nice looking UI in AWS where you just have to go to the Amazon EC2 instance console and you need to spin up the machine. That's it. So the agility is definitely one of the key aspects of cloud computing. Of course, we have discussed measure service, resource pooling, yes. So resources being dynamically assigned, reassigned to achieve utmost optimization of the utilization of resources. So these are the key areas, key ingredients of cloud computing. So let's move on to the AWS. We'll start with the discussion of the core infrastructure. Now, this discussion would be centered around the global infrastructure of AWS, which caters to the global demand of the services. Now, how it is achieved is through the data centers that are interconnected. And then there are logical groupings into availability zones, regions, and edge locations. So, at the very core, there is a data center in which there will be server racks that will be connected with highly redundant network. So, these data centers would be equipped with redundant power, networking, connectivity, ensuring high availability for applications. Availability zones are nothing but the clusters of interconnected data centers. So, typically, an availability zone will have two or more data centers interconnected with highly redundant network. By running your system in multiple availability zones, you can enhance fault tolerance and achieve higher level of availability. So at the very high top level, there would be a region which would be nothing but a geographical separation. Like could be a region in United States, could be a region um, in some other geography around the world. So in that region, we'll have two or three availability zones, which would be nothing but a cluster of data centers. So this kind of structure promotes high availability, fault tolerance of resources, and increases data durability through replication of your data in two or more. It could be availability zones, could be regions if you want to promote regional durability. So this is how the core infrastructure looks like. I have one diagram as well that depicts the global infrastructure map of AWS. And there are some numbers, as you can see, 99 availability zones with 31 geographic regions around the world. And then, of course, there are always plans for expansion. So this is how the infrastructure looks like. So let's move on to the next slide here. The other critical aspect is edge networks that helps AWS deliver content with very less latency to the users that are spread out globally. Typically, how it is achieved is AWS global cloud infrastructure is a network of point of presence, which is known as edge network. So the network consists of edge locations and regional edge cases. So how it happens is, let's say if there is a server that is sitting in California and a user from Australia is requesting a content from that server. Typically, the content will not be traveling far away from California to a city located in Australia. Typically, the content would be picked up from a cache that will be located near to the city in Australia, the nearest city. So, this is how the content is distributed with minimal latency, and this technology is referred as content delivery network. There are a couple of services that are centered around this concept. We have Lambda Edge and we have CloudFront as these two services. They uh, deliver and intelligently routes user request to the nearest edge location, minimizing the distance and time required for data to travel back to the origin server. So this was all about edge networks, and let's cover briefly about the cost drivers and billing models in AWS. For any cloud provider, the core drivers for cost are compute, the storage, and the network. So, how much compute capacity is being utilized would be responsible for cost, along with how much storage is being utilized. Also, how much data is being transferred out of the network. So, data transfer over the network will also contribute to the cost. So, these are the three key drivers basically. As you can see, compute, storage, and outboard data transfer. Let me go back. Um, so, there are various kind of pricing models which varies depending upon what product and service we are talking about. So, for example, in case of compute instances, there are models like on-demand instances, which is nothing but it allows you to pay for compute or database capacity on an hourly or second basis. There are no commitments you need to make, long-term commitments or any upfront payments. You only pay for your usage. Then there are the concept of saving plans where you commit for a longer time period, could be 1 or 3 year term, and then you can enjoy the discounted rates. Then there is a concept of utilizing spare computing capacity in the form of spot instances, which um, which is kind of a cheap option with rates going to 90% off the original on-demand price. So price mechanism allows to take advantage of available resources with no upfront commitment. Then there are reservations you can make for the capacity if you're very much thorough and sure about the usage patterns and trends in your project. Yes, you can make a reservation of your computing capacity, which again would be a good discounting use case up to 75%. So there are more pricing and cost optimization strategies as well, which will be covered in more detailed uh, discussions. But the intention here was just to cover how the cost is calculated and what pricing, what billing models are being used in AWS. I think that will be all for this discussion, and we'll be covering more area around the costing and billing models in upcoming discussions. Thank you all for your time.